Hello everyone, so we're continuing the conversation on acids and bases, and in this example we have a bit of a qualitative discussion on a mixture of, or what happens if you mix two solutions. So it says you mix 30 milliliters of a 0.15 molar solution of sodium hydroxide with 30 milliliters of a 0.15 molar solution of acetic acid. What molecules and ions exist in the solution? Alright, I'll list them in order of decreasing concentration. So let's first look at what is the reaction that takes place once we've mixed these two solutions. So of course we have sodium hydroxide in aqueous solution reacting with acetic acid. So that's CH3, CO2H, aqueous. Sodium hydroxide is a strong base, so it will form a strong product forming reaction. And it is a base, in other words, it will deprotonate the acid, or the acid will donate a proton to it. It forms the acetate anion, CH3CO2 minus, but remember there is sodium present in this. In other words, it will form sodium acetate in principle in aqueous solution. And then of course you have OH plus H plus, and that gives you some water liquid. Alright, so interestingly enough, I mean, you can analyze this quickly if we look at the number of mole of sodium hydroxide. So just checking the stoichiometry. So that's equal to the concentration of sodium hydroxide multiplied by the volume of sodium hydroxide, right, is equal to 4.5 times 10 to the negative 3 mole sodium hydroxide. Remember to work with volume in liter. And we can also calculate the number of mole of the acetic acid. Right, gives 4.5, also gives 4.5 times 10 to the negative 3 mole acetic acid. Alright, so that means after the initial reaction there are only products left. So therefore, after right? But what can happen after the initial reaction? Well, if you look closely here, what forms? So water forms and sodium acetate. Now sodium acetate contains the acetate anion and sodium, but the acetate anion is of course CH3 CO2 minus aqueous, right? And that can actually react with water again. Why? Because the acetate anion has a Kb value of 5.6 times 10 to the negative 10, meaning it will form a slightly basic solution, or slightly basic equilibrium, where it again forms CH, where it forms acetic acid again, aqueous, plus hydroxide, aqueous. Alright, so that means after reaction, therefore, therefore after, let's say after mixing the species present, are what? So the first one, probably the one that's going to catch you out. Remember, there is sodium ions, or there are sodium ions present in this mixture, because sodium is a spectator ion, so there's sodium there. There is the acetate, right? The acetate anion is present. Okay, water doesn't have a concentration, so we don't have to consider that. But what forms again? The acetic acid forms again because of the equilibrium that the acetate anion forms with the water, right? So it's present again, even though it reacted initially and was consumed fully by the sodium hydroxide, it reforms because of the equilibrium the acetate anion has with water. All right, and because of that same equilibrium, hydroxide anions also form. All right, so that's interesting. So that means actually after mixing, we have everything that we started with, as well as the products. All right, but the question is, what are their concentrations in order? Right, and you don't have to calculate this to know this. So the one with the highest concentration is going to be the spectator ion, right? Because it's a spectator. It's not doing anything. It's just spectating. It should have the concentration of the sodium hydroxide, and you see the concentration of the sodium hydroxide is equal to that of the acetic acid initially, so it's the same number of moles, so it shouldn't be higher than anything else. Then the next highest should actually be our acetate anion, right? So it should be the acetate anion, whatever its concentration is at equilibrium. Now its Kb value is very small, so you'll probably make an approximation. So it could be the initial amount, right? The initial amount that reacts here, or you can leave it as the amount at equilibrium. And that means it could in principle be equal to the amount of sodium, but I mean in general sense it's about larger, or it's a bit less, perhaps equal to the amount of sodium. Alright, then the next two species are, because of the small Kb value, their concentrations are much less than our acetate anion, and that is the concentration of the acetic acid that forms again because of the equilibrium, right? So that's the amount of at equilibrium, and that must be equal to the amount of hydroxide at equilibrium, right? And if you struggle to see that, remember to do your ice table. You just have to do the ice table and convince yourself that these values are x, and this is some initial value CH3CO2 minus x, right? And then you should convince yourself that, okay, yeah, that's why they have that order and how you can quickly get to that. Okay, so that is our concentrations in order. The spectator ion is just a spectator, so it doesn't do anything. Then we have a product that forms the acetate, and the acetate can undergo the equilibrium, right? So because it undergoes the equilibrium, its concentration can decrease a little bit, and actually it will then, the products that it forms is again, in fact, the acid and base that react to form it in the first place. All right, so that is it for this question. It's a qualitative way of looking at the similar type of questions that we've looked at before, of an acid and base forming a product that or an ion that can then hydrolyze with water and form a new equilibrium. All right, I'll see you in the next video.